Okay, in the second vlog in this series for simplifying radicals and radical expressions, in the previous vlog we talked about the multiplication rule or the product rule. Now we're going to talk about the quotient rule or the division rule for radicals. Okay? Again, a and b are real numbers, square root of a and square root of b. They're positive numbers also, they're not negative numbers. And b may not equal 0 because b being the denominator, we cannot divide by 0. It's undefined. So the square root of a over b is the same thing if we were to say square root of a divided by the square root of b. Now we'll do some examples here. So I wrote this on purpose to show what we're talking about. A can equal 0. So a can be is greater than 0 or equal to 0. But it cannot be a negative. If we had a negative under the radical, or in the square root, it would be an imaginary number. In this series, we're not discussing imaginary numbers. It's possible to be done. It's a different kind of number, complex numbers, but we're not going to do that here. With the denominator, b must be greater than 0. It cannot equal 0. Okay? With those two things in mind, we'll proceed. Now my rule says what? The square root of 16 divided by 25 is the same thing if I were to break up the square root and say the square root of 16 over the square root of 25. Now, both our numerator and denominator are perfect squares. They have square roots. 4/5. Pretty simple. Now our next example. Okay. As we split up our radical, we talked about in previous vlogs plus and minus. The answers are really plus and minus 6, plus and minus 4/5. But right now we're going to concentrate on the positive answers for now. Now the square root of 36 is 6, but the square root of 7 is not a perfect square. So really, I would leave it right now as square root of 7. Okay, so now our last example for this quotient rule. All right, so the square root of 100 over 81 is equal to the square root of 100 divided by the square root of 81. Then becomes 10/9, and I convert to a mixed number, 1 and 1/9. Now, these examples, all denominators had a square root. There were no square roots in the denominator. The square roots are not allowed to remain in the denominator, but we're not going to face that for now. Now, next, we're going to work on simplifying or breaking down radicals using our two rules we just learned, the quotient rule and the multiplication rule. Now, breaking down radicals, simplifying them. What does it even mean? Numbers have factors. If we had, say, let me think. Okay, those are all the factors of 24. Now, if you look at the pairs, 1 and 24, 2 and 12, remember, I'm working on square roots and perfect squares. If I choose 24, it's a square root of 24, I can change it and I can write it a different way. I can write it with the factors that we just, with the product rule. So the square root of 24 would be the square root of 3 times the square root of 8, or the square root of 2 times the square root of 12. But we're working on or trying to find perfect squares. We want a perfect square in there. That way it simplifies it fully. Watch. So there's our answer. That's how we would break down the square root of 24 using our product rule. So the square root of 24 is equal to, oh, okay, I can think about writing it as 2 times the square root of 6. They have the same value. We're going to do other examples using coefficients, okay? Using numbers. Okay, so we have 3 examples to work on with numerical examples. None of them are perfect squares in and of themselves, but they contain factors that are perfect squares. If we think about 12, we just said 24, 4 times 6. We know 4 is a perfect square. Now look at 12. There's a 4 there. So if we divide by 4, there's a 3. So, okay, here we go. And there's our answer. That's how it all falls together. Right now, I'm not going to write out the full, square root of 4 times 3. I'm going to jump to the square root times the square root. Now let's look at 72. There are several factor pairs for this one. 1 and 72, divide by 2, 36. Divide by 8 is 9, and then it's 9. I could do 8 and 9. Let's try that and see what happens. Okay. So far, so good. Square root of 9 times the square root, I'm sorry, square root of 9 is 3. So 3 times the square root of 8. But 8 has other perfect squares remaining inside it. 4 would work. So we got more work to do. We're not done. So there's our fully simplified answer. The square root of a I recognized as not being finished. It wasn't fully simplified. I could keep going. So 72, there's a shorter way to do this if you see a different pair. If I realize 2 times 36 and 36 is a perfect square, that's the largest perfect square in there. And I can move to our final answer much quickly. Okay, my point, showing both ways, is if you were to overlook the best factor pair, you can still go, you can still keep working, it will work out. But if you see the best possible choice first, your answer is just, you arrive at your answer quicker. Now, there's no more factors of square root of 2, no more perfect squares. So that's final. Now we'll look at the square root of 288. I happen to know my squares, so I know 12 squared is 144. I know 2 times 144 is 288. Now, I suggest that you all learn your perfect squares, probably 1 through 12 or 15, maybe even 20, and it will help with this process. Oh, I'm looking at this final answer. 12 times the square root of 2. Thank you, and I'll see you next vlog.